So in my previous video, I introduced the concept of policy as code and tried to make the argument of why it exists. If you missed that video, in short, policy as code is basically a tool that we've had tremendous success with pairing with your traditional AI agentic limiting tools, like your rule files, your skills, etc. And it introduces a static set of rules and scripts that basically contain drift at scale. If you want to see that whole video, check it out. It's on my YouTube channel. In today's video, what I want to get into is actually what this looks like and how you can build out these policies. This is not going to be a getting started video. I'll have another one of those on the channel so you can find that. But it is going to be trying to show you like how this works at scale and how you can run it and how you can build it. What you can see right here is this is actually one of the rule sets I have for this Elixir suite. So with that, let's get into it. Look forward to diving in. Okay, before we get into it, as a reminder, my name is Ben Fellows. I do a lot of content on QA as well as now just general engineering, things like agentic pipelines, things like policy as code, living documentation, all kinds of things. So if you like that, please subscribe to this channel. It goes a long ways. I'm trying to do a lot more videos. I also want feedback on this because like generally speaking, I've not done a ton of videos and I think I could probably be better at it. Okay, so once again, if you're new to this, what is policy as code? I have a whole video on this, but essentially the concept is that you introduce a set of rules that are extraordinarily comprehensive that govern everything from architecture to rules on what you can import where to, frankly, even what documentation needs to be available. And the idea basically is that you run this every time you're also doing agentic development. So you give a prompt, it tries to run code, and then it runs its policy as code suite and it flags errors. And I actually might have, and let's see if I have it, an example of its one that I did. Okay, yeah. So let me pull it up. Great. So this is an example of an output. Now, in this case, I haven't worried about cleaning it too much into a report or anything like that. It's just more for me and some work I was doing. In short, you can see, so I did some development earlier this morning. I ran the suite. It currently takes around 4 to 5 minutes. I think I can probably optimize that much further because it does feel like it takes way too long, but the code base is quite large. And in short, from the development this morning, it found around 302 errors. Now, I had also messed a little bit with some of the rules, so you have to be really careful with changing the rules. Generally speaking, you want to be never changing them. Like your rules should not be changed. Like they are your source of truth. They guide everything. And you can see now it's found all these violations, right? And this is anything from missing attributes to missing test IDs to this is my component library and looking for like where is supposed to live and what. 6 apps missing their observability things as well, right? So this is the output of it. And the concept is this idea that you use this to constrain AI drift, and it frankly works really well. So how do you build it and what is it at scale, right? And so what is at scale is 3 core levels. You have your evidence gathering, you have your rules, and then you have your gates. So the evidence gathering at scale, why it becomes complex is a couple things. One is you want to figure out how to optimize the scraping of your code base essentially, right? Like you don't want every rule to do a full scrape of the code base. So you end up essentially creating like evidence buckets that basically different rules need to look for different things, right? And so you create a bunch of different evidence buckets that the rules all then are mapped to and the rules look at. And then you also have your whole gate system, which is basically determining when and how stuff fails. This is more important when you try to introduce it into maybe the idea of a CI/CD flow. Most of what we're doing right now is for like local development, but it is an interesting tool, the idea to introduce this idea of like release warn. For the most part, we try to always clean up anything that is either a hard fail or a warn. And then you have all your rules, and we'll talk about that. All right, so 1 pipeline, 7 subsystems. Let me zoom in on this because clearly probably it's going to be too hard to read. You have your source code, your ST parser, that then compiles into an artifact reader. You have your manifests and routes, right? That all then goes into evidence cache, which is basically, I forget where that is. I'll have to get back to you about that. And then that becomes evidence store and rule registry. So like the benefit of this is that you can then add logic like when you're doing changes, if you've only changed certain files and then the rules are not mapped to those files, you can use some of the evidence cache and you don't have to run full scans every single time. Transparently, some of this stuff I have yet to sit down and really fully go through. I need to work on continuing to optimize this. So I'd love people's feedback on how and what to do. You have your runner, and then you have your findings, you have your waiver concept. Waiver concept is basically the idea that you want to either allow for certain exceptions, right? So like my general belief is that code is just a massive set of patterns. For the most part, you can almost codify all of those patterns and how they should work. But at the same point, there are times when you want waivers. And so you have the ability to do waivers. This is probably the biggest risk point in the whole concept though, because as soon as you introduce the idea that waivers are possible, AI tries to introduce them like everywhere. So we have a whole system around AI not allowed to introduce waivers, and then we periodically audit what it has been flagged as a waiver. And then you have the output here, which is your reporter HTML, which I just showed you. And then you have the gate evaluator. Eventually, I think you should do something like an HTML roll up. That's like very easy to do. We've done stuff like that, but it's worth doing. So what does a repo actually look like? So right now, we're not like packaging this or anything like that. Like eventually there's a world in which maybe you would just turn this into an NPM package, or I think it's hex files for Elixir. But if you're just doing it yourself and building it yourself and you want the fully built out version of it, you have basically a Polyscope's cold repo, your SDK, which has all rules, findings, context. You have an engine concept, your extractor concept, and then you have all your rules sorted here. And then you have a reporter concept and so forth. So in terms of the full-blown architecture of it, I will just the same thing, be super transparent that I've been more focused on general on trying to make sure that all the rules are accurate than I have been on like optimizing the actual whole concept. That's probably going to be a priority for me in the next like month or so as we're doing more of this. This is going to be very hard to read, but what happens when you actually run it, it goes down this whole process, right? So first you have your CLI, excuse me, which at this point, we just have AI do. So like part of our agentic pipelines now at this point is that after a change, AI is just told to run the policy, rules system, any errors, make sure the code is compliant. And the key thing is that the code, like it always has to make sure the code becomes compliant with the rule system, not ever that the rule system should somehow become compliant with the code. This whole thing fails if you're not capable of building out a set of rules that govern software development. And like genuinely what we're talking about is like thousands of rules possibly long-term, right? It's everything from patterns to anti-patterns to architecture, etc. Which once again, like I'll pause and say this was never, I think, feasible or that great. Here, let me move my face, by the way. This was never particularly feasible before AI. Oh, wait, my mouse is over here. And what's interesting about it is just this idea that like now with AI, writing and governing all these rules and going through them and figuring out like what I like or not. It wrote all the rules in an afternoon. I spent a couple hours with a couple other folks going through all the rules, deciding if we liked them and they were valid. And now we have 100,000 lines of rules that govern software development on this project. I never would have sat down and write 100,000 lines of rules before this, particularly that are bespoke to this project. And like, I can show you, by the way, what's unique about this project and challenging is the whole concept of the project is that you have multiple apps that are being developed against a shared module system that basically presents a menu system for contracts. This is a whole different thing. But the idea that, let's imagine you have like billing, right? This billing module actually has hooked up to Stripe. It has multiple different concepts of how you could do billing, per seat usage, variety of other ones. And then you have your apps that basically subscribe to the module with a contract. It decides what you want, how it wants to use billing, what kinds of billing, the schema, the UX UI all lives in the module. So then that just is basically imported into the app. And then the app is just a shell basically for that concept. A lot of our rules are based around like what contracts need to be in place, what rules, like all of these different ways. And so like we have rules governing how the shared modules work. We have rules governing how the apps work, etc. And so when you run it, right, and we can talk about this, but basically you have your runner, it goes down, it goes through all your checks, filters, right, and then evaluates and it emits it, right? This is repeating it a little bit, build evidence context, build rule registry, preload, yep, metadata, one predicate, that's it. Yep, every rule is a module with declarative, right? So 4 types carry the whole engine. This is probably the simplest way of explaining it. You have your rules, you have the context component in the code, and then you have the evidence objects, and then you have all your findings, and then you have your waivers, right? Right now, I guess what I would say is this is not packaged and put up into GitHub. If there's interest, I guess I can package this and put it into GitHub. Generally speaking, my belief though is that like in the world of AI, like people should take something like this and run with it as opposed to just like pulling down a package. But certainly, I guess if you want a general like framework packaged up and so all you have to do is just write the rules, I'm more than happy to do that. Yeah. And then basically it's like that, right? And then it comes down to, yeah, here's the whole gating system. Is it waived? And then how does it gate? And then so forth. 3 shapes, markdown. This is a little reporting concept. Great. And then 8 design decisions you have to make. Let's see here. Evidence first semantics. Declarative rules as data. Yeah, this is not super important to go through actually in this steps. So, and once again, I think I had another, in the previous video, I talked about all the different kinds of things that we do as rules, but I'll mention this. Basically, you have your visual UI boundaries, like architecture things, webware, like if we just look, right? So this is everything from like route structure to how the HTTP works, to imports, to middleware order, etc. It is truly governing everything about, in theory, basically every decision that a developer could make that is possible to be turned into a pattern, right? And personally speaking, I think it works really well. I have a lot of evidence to say it does work really well. I'll be publishing that evidence, but yeah, this is what it is from an architecture perspective, how it breaks down. And then once you have it in place, it's as simple as just, hey, run the policy rules. Is it clean? Good. Then you run all your test automation. Is it clean? Good. Then you can be very confident at an agentic perspective that the code is both compliant with how you want everything architected, done, etc., as well as all the tests, right? Is it perfect? Absolutely not. Am I still finding rules that I need to be added? What I tend to do now is when I find drift, I then ask AI, like, how did this get around the rules? And most often is the case is I just didn't have a rule for it, right? Now, what's really cool about it is I'm getting so much less drift than I've ever gotten before. So there's less and less rules that I'm having to add. And to me, that's an indicative component that this is really working. Yeah, if you have questions, drop it in the comments below. I will be doing more videos on this. Hit me up, LinkedIn, YouTube, anything. My name is Ben Fellows. I run a company called Loop QA. If you actually want like consulting or a course on this stuff, we're considering launching that stuff too. Feel free to comment if you're interested. Otherwise, unsubscribe. I appreciate it. Talk soon. Bye.